Okay, so we're going to start with polar functions and practicing working from polar coordinates to rectangular, rectangular to polar. So maybe this looks a little familiar. If not, here we are. So here's the rectangular coordinate system where we work with a ordered pair x comma y. And we can find a corresponding point on the polar coordinate system with r comma theta. So these 2 points correspond to each other. So if we look at this figure below, here's an example where 2, 2 has polar coordinates 2 root 2 comma pi over 4. All right, let's take a look at graphing each point. So what we're going to do is we're always going to start with theta. So identify where 3 pi over 4 is. And so here, it's going to go like this. This is 3 pi over 4. And then I want to count from the origin 3 units away. So I'm going to count 1, 2, 3 and put a point there. And that's it. Let's take a look at the next one. So it's negative pi over 3. So negative pi over 3 is the same thing as 5 pi over 3. But this time it says negative 2 is our radius. So what we're going to do is we're going to extend the line, because if it's a negative radius, we're going to go in the opposite direction. So instead of counting towards negative pi over 3, we're going to count towards 2 pi over 3. And we want to count 2 units. So it's going to go 1, 2. So here's our negative pi over 3 and our point. Okay, here's our rectangular and polar conversion. So changing polar to rectangular, it's r equals cosine theta, y equals r sine theta. And then rectangular to polar, how do they relate? Well, r squared is equal to x squared plus y squared. That should look familiar. And tangent theta is y over x. So first we're going to plot each point with the given polar coordinates, and then we're going to find the corresponding rectangular coordinates. Okay, so starting with 5 pi over 6. So 5 pi over 6 goes here. But I notice, again, I have a negative radius. So I'm just going to extend the line. So here is 5 pi over 6 showing the direction. And then I'm going to count 1, 2. So now what we want to do is we want to find the rectangular coordinates. So we have x equals r cosine 5 pi over 6, and y equals negative 2 sine 5 pi over 6. So here we get negative 2 times negative root 3 over 2. And here we get negative 2 times 1/2. So we get root 3, and we get negative 1. So our ordered pair is root 3, negative 1. And yeah, that we can kind of like, root 3 is about 1.7, negative 1. So we want to just confirm that looks correct. We're in the right quadrant. Okay, next one. If you want to pause and try this one on your own, go ahead. So x equals 2 root 3 cosine 2 pi over 3, and y equals 2 root 3 sine 2 pi over 3. So we get 2 root 3 times negative 1/2. So that gives us negative root 3. Here we get 2 root 3 times root 3 over 2, and that gives us 3. So we get negative root 3, comma 3. And when we graph that, sorry, I should have graphed it first. Here's 2 pi over 3. And when we're counting 2 root 3, so that's about 2 times 1.7. So it's going to go a little past the 3. So 1, 2, 3. Doesn't have to be perfect. There we go. Okay, representation of polar coordinates. So we have infinitely many sets of polar coordinates. So if you imagine, we can go around the unit circle any number of times and we'll get to the same location, right? And the other way we could also approach it is you could do plus pi n, but do the negative radius. So let's plot each point with the given rectangular coordinates and find two sets of corresponding polar coordinates. Okay, so we're going to graph -1, 1. That's easy. Okay. And now I want to find two sets of corresponding polar coordinates. Well, remember, tangent theta is equal to y over x. So theta is going to be 5 pi over 4, right? And then let's see, x squared plus y squared equals r squared. So 1 squared, -1 squared plus -1 squared. So r is r is root 2. So one ordered pair would be root 2 comma 5 pi over 4. Or we could we could add 2 pi, or we could make this a negative r and make that pi over 4. That would also work. Okay, next one, -root 3 comma -1. So that's going to go here. So tangent theta equals -1 over -root 3. So that's going to be 7 pi over 6. And then x squared plus y squared equals r squared. So r equals 2. So one ordered pair could be 2 comma 7 pi over 6. And here we'll do another, let's add 2 pi this time. So 2 and 19 pi over 6. Or we could do -2 comma pi over 6. All right, let's graph the set of points whose polar coordinates satisfy the given condition. Okay, so we're given that r equals 3. So just remember, x squared plus y squared equals r squared. So x squared plus y squared equals 3 squared. So this is going to be a circle with radius 3. So in fact, anytime it just says r equals a constant, it's just going to be a circle with that radius. And then let's say we have pi over 3, theta equals pi over 3. So recall, tangent theta equals y over x. So tangent of pi over 3 equals y over x. Tangent of pi over 3 is root 3. So y equals root 3 comma x. So that's going to be a slope of, again, about 1.7. And there's our line. Okay, next we want to change the polar equation r equals 4 sine theta to rectangular form, and then we want to graph it. Okay, so recall, x squared plus y squared equals r squared. And remember, we also know y equals r sine theta. So if r equals 4 sine theta, and if we multiply both sides times r, we get r squared equals 4r sine theta. So take a look. We can replace r squared with x squared plus y squared, and we can replace r sine theta with y. So we're going to have x squared plus y squared equals 4y. Okay, I'm going to move everything to the left side, and it's probably been a while, but we are going to complete the square to put this in standard form. So can't do anything with the x squared, so I'm going to take y squared minus 4y. I want to complete the square, so I'm going to add 4. Whatever I add to the left side, I have to add to the right side. So we have x squared plus y minus 2 squared equals 4. So this means this is our graph. Okay, and so what do we, just a quick reminder, x minus h squared plus y minus k squared equals r squared. So the center is always going to be hk and the radius is r. So we have 0, 2 is our center and our radius is 2. So we'll go out 2 units and graph it. Okay, so the last thing we're going to do for this lesson is look at slopes of polar curves. So the first thing that I want to look at is we can define polar curves parametrically. So x is equal to r cosine theta, which is the same as f of theta times cosine theta, because r is f of theta. And y is r sine theta, or f of theta times sine theta. Slope, right? Remember, dy dx. So we're going to do the same as we did in parametrically defined functions. We're going to do dy d theta over dx d theta. Okay, so last example we'll do for this part of the lesson. So first thing we want to do is what I had mentioned above. We're going to redefine parametrically. Okay, so x is equal to 2 sine 3 theta times cosine theta. And what we want to, and then y equals 2 sine 3 theta times sine of theta. So for each of these, we want to find dx d theta and dy d theta. So yes, we're going to have to go back to the product rule. So let's see, that's going to be 6 cosine 3 theta cosine theta minus 2 sine 3 theta sine theta. And over here, we're going to get 6 cosine 3 theta times sine theta plus 2 sine 3 theta cosine theta. I know I went through that pretty quickly, but I'm sure you can probably go through and check. Okay. Now let's do dx d theta, and we want to evaluate that at theta equals pi over 6. So that's going to be 6 cosine of pi over 2 cosine of pi over 6 minus 2 sine pi over 2 sine pi over 6. Well, all of this is going to be 0. And so we're going to have, this is 1. This is 1/2. So we should get -1. And then let's do dy d theta evaluated at pi over 6. So we're going to have 6 cosine pi over 2 sine pi over 6 plus 2 sine pi over 2 cosine of pi over 6. Again, this all becomes 0. This is 1, and this is root 3 over 2. So we get root 3. So for dy dx, we're going to get -1 over root 3. Or, sorry, dy dx. Or dy d theta goes on top. So it's going to be negative root 3. So our tangent line is going to be y minus 1 equals negative root 3 times x minus root 3.